Hey, Algebra 2 students. Today we are going to talk about the inverse functions, day 1. We are going to learn about the inverse function and how to find it. So, first thing we want to talk about is what is the opposite, or how do you undo addition? So, for example, you're solving an equation that has like x plus 5. You undo that with subtraction. That's called the inverse operation. Same thing with multiplication. Division is the inverse operation. Okay, but what about when something is squared, or when something is being cube rooted? Whoops, cube rooted. Okay, what is the inverse function of that? That's what we're thinking about today. So if you started to make some ideas in your head that maybe the inverse function to something squared is the square root, you're right. The inverse function to something that's being cube root is x cubed. So we'll use that to guide us as we go through, just to get you thinking though about an inverse operation or an inverse function. So these are the 4 steps we're going to take today in finding the inverse function. First of all, if we have a function defined as f of x, we will let it equal y. We're going to switch the placement of x and y in the function. We're going to solve for y, and then notate y as f inverse of x. So again, this says f inverse of x. That's how that's read. Okay, so here we go. Let's try. Alright, so first we have a function written as y equals 3x minus 7. It says to find the inverse relation of the following functions. So it's already y equals, so the first step we take is we are going to switch x and y. So our new function will be x equals 3y minus 7. Once we have switched the placement of x and y, I now solve for y. So I'm going to add 7 to both sides, so x plus 7 equals 3y. And now divide everything by 3. You could either write this as 1/3 x plus 7/3 equals y. You could have left it as x plus 7 over 3. It just depends on what your teacher's going to want. Both are equivalent. Now, final step. Instead of y here, we're going to write this as f inverse of x equals 1/3 x plus 7/3. And done. It's as easy as that. Finding the inverse, switch x and y, solve for y. Let's do it again. So over here in this one, it says f of x, so let's rewrite that as y equals 2/3 x plus 6. Now our first step is switch x and y, so I'm going to rewrite this as x equals 2/3 y plus 6, and now solve for y. So subtract 6. Okay, and how do we get rid of 2/3? Well, we multiply both sides by the reciprocal. Now, notice on the left, when I multiply both sides, that includes both terms, which will require me to distribute that fraction. So this becomes 3/2 x, put 6 over 1, 2 goes in there twice, times 3 is minus 9 equals y. And finally, we're going to notate this as f inverse of x equals 3/2 x minus 9. Done. Alright, well let's try some that are a little bit more complicated. So, right away we take a look at this one. Okay, the inverse of x cubed, we talked about a minute ago, was a cube root. So let's hope we get a cube root in our answer. Let's start by defining f of x as y. So y equals x cubed plus 6. Switch the x and y. So x equals y cubed plus 6. And now we're going to solve for y. Start by subtracting 6. X minus 6 equals y cubed. And now, just like when we were solving equations, to remove that cubed off of the y, we are going to cube root both sides. Okay, now be careful, because you are cube rooting the entire side, not individual terms. So when you solve for y, you get the cube root of x minus 6 equals y. both the x and the 6 are under the same radical. Final step here, f inverse of x equals the cube root of x minus 6. Okay, let's do it again. This time we have a function f of x defined as a quartic. Notice that we have a domain restriction here. Okay, I'm going to write that down, domain restriction. And you're going to see in a minute how that domain restriction comes into play, but that is separate from that function. So we'll do the same process. Let f of x equal y. Y equals 2x to the 4th plus 5. Switch x and y. X equals 2y to the 4th plus 5. And now solve for y. Subtract 5. We need to, sorry about that. Come back, video. There it is. We need to divide both sides by 2. Okay. This time I'm just going to leave it as x minus 5 over 2 equals y to the 4th. Now, to remove the y to the 4th, we are going to 4th root both sides. And when I do that, remember, when you even root both sides of an equation, I get plus or minus 4th root of x minus 5 over 2 equals y. Now, my final step when I'm going to write what my f inverse function is, this is when my domain restriction is going to come back into play. Okay, notice that I have only for positive x values, but I have the plus and minus here. Well, to go along with my domain restriction, when it says x is greater than 0, then I will choose just the positive side of my inverse function. So I will say f inverse of x equals the 4th root of x minus 5 over 2. Now, if there was no domain restriction, I would include both the plus and the minus. If this would have said x is less than 0 instead, then I would have picked the negative side of that plus and minus. So keep in mind that plus and minus, when you even root, check out if you have a domain restriction. All right, that's it. You've got 4 examples. 2 very straightforward like the first 2, 1 cubic, 1 quartic. Notice your domain restriction here. Okay, this is values that are less than 0, so think about that when you get there. All right, see you guys tomorrow. Thanks for watching my video.